Right now, on an orbit we can no longer see, the most dangerous asteroid ever discovered is running silent toward its next appointment with Earth. It will miss. We know that now. But for 1 month in 2025, it did not miss in our calculations. It climbed to the highest impact odds ever recorded, having been found 2 full days after it had already swept past the planet. Its name is 2024 YR4. This is the story of how we caught it too late, cleared it just in time, and then lost sight of it again. There is a telescope in the mountains of Chile whose entire job is to give warning. Its name is a kind of promise, the Asteroid Terrestrial Impact Last Alert System. The last alert, the final warning before something reaches us. On the night of December 27th, 2024, it found the most dangerous asteroid it had ever seen. And it found it 2 days too late. The rock we now call 2024 YR4 had already come. On December 25th, it slid past the Earth at a distance of roughly 800,000 kilometers, a little more than twice as far away as the Moon. It was only because of that close pass that it grew bright enough to notice at all. By the time the survey logged it, measured it, and understood what it was looking at, the object was already receding into the dark, pulling away from us at the speed of a thing that owes us nothing. We convinced ourselves for a long time that this was not how it would happen, that the next serious threat would appear on approach, with years to prepare. Instead, the system built to see them coming caught this one going away. That single fact, found after the fact, is the reason this story should sit with you long after the numbers are cleared. Because the danger here was never really a date on a calendar. The danger is what it revealed about the size of our blind spot. For a few weeks in early 2024, YR4 became the most dangerous asteroid ever catalogued. Not the largest, not the closest, but by the one measure that governs how seriously we take a rock, the calculated probability that it would strike our planet. Nothing in the modern record had ever scored higher. On January 27th, 2025, it was rated level 3 on the Torino scale, the 10-point index astronomers use to communicate impact risk to the public. The scale was devised by Richard Binzel at the Massachusetts Institute of Technology, precisely so that a number, not a rumor, would carry this kind of news. Level 3 means a close encounter meriting attention, with a greater than 1% chance of collision. Most asteroids never rise above 0. This one climbed to 3 and stayed there for weeks. That rating did something that had never been done before. It triggered the formal machinery of planetary defense. The International Asteroid-Warning Network issued a memo. The Space Mission Planning Advisory Group was notified. The United Nations Office for Outer Space Affairs was formally alerted. These groups had existed since 2014, drawn up for exactly this moment, and for a decade they had never once been called into action. 2024 YR4 was the first. Richard Moissl, who heads the European Space Agency's Planetary Defence Office, found his team at the centre of a response the world had rehearsed only on paper. Somewhere in the records of an ordinary winter, humanity opened the emergency plan it had written for itself and had never once had to read. The impact was projected for a single date, December 22nd, 2032. Christmas, 7 years out. Astronomers began the strange work of watching a rock while a clock ran quietly behind it. To understand why this rattled the people who watched the sky, you have to understand the story they had been telling themselves. And that story had a name. Apophis. Apophis was discovered in 2004, and for a brief window it reached level 4 on the Torino scale, higher than 2024 YR4 would ever go, with impact odds near 2.7%. It became the face of the asteroid threat, the rock every headline reached for. but Apophis behaved the way the textbooks said a threat should behave. We found it years ahead of its close approach. We tracked it, refined its orbit, and learned eventually that it would miss. The system worked because the object gave us time. 2024 YR4 is not Apophis. That is the quiet correction at the center of this whole story. It did not announce itself on the way in. It carried a higher impact probability than Apophis ever did. And it was found not with years of runway, but 2 days after it had already gone by. Apophis briefly held the higher Torino number for a simple reason. It is a far larger rock, and the scale weighs size heavily, because a bigger body does more damage. But size is not the same as the odds of being hit. On pure probability, the smaller newcomer had passed the older famous one. The comparison matters because Apophis taught us to expect a warning. This one showed us how easily that expectation breaks. The name everyone knew belonged to the rock that behaved. The name almost no one learned belonged to the one that did not. Here is the part that made astronomers stop sleeping well. In the days after discovery, the impact probability did not fall. It rose. This is normal, and it is one of the more unsettling facts about tracking a new object. When a rock is first found, its future path is a smear of possibility, a cone of uncertainty stretching across the solar system. Earth sits somewhere inside that cone. As you gather more observations, the cone narrows. And if the planet is still inside the shrinking region, the probability of impact climbs, sometimes sharply, right up until the moment the planet finally falls outside the cone, and the odds collapse to nothing. For 2024 YR4, the climb was steep. By February 18, 2025, NASA's Sentry system, run out of the Center for Near-Earth Object Studies, put the chance of an Earth impact at 3.1%. The European Space Agency's independent system, called Aegis, working from its own observations and its own math, landed at 2.8% that same day. That agreement was its own kind of chill. 2 separate teams, 2 separate models, both arriving at the same unwelcome answer. 3% does not sound like much until you attach it to a city. It means roughly a 1 in 30 chance that a rock large enough to erase an urban area would arrive on a known date, the sort of odds you would never accept for anything you loved. Alan Fitzsimmons, a planetary defence astronomer at Queen's University Belfast, spent that stretch explaining to the public that the most likely outcome was still a miss, while the honest scientists among them admitted they could not yet promise it. Think about what it means to carry a number like that for a month, not knowing which way it will finally break. And then it broke the good way. By February 23rd, with a longer arc of observations, the Earth fell out of the cone. The odds dropped to essentially zero. The Torino rating fell to nothing. The city killer was, for Earth, no longer a threat at all. But the astronomers were not finished looking, because there was still the question of exactly how big it was, and there was still the moon. The trouble with a rock like this is that a telescope on the ground can tell you where it is far better than it can tell you what it is. A small object glimmering in reflected sunlight could be a large dark stone or a smaller, brighter one. The two look nearly identical from 250 million kilometers away. To know the true size, you cannot measure the light it reflects. You have to measure the heat it gives off, so astronomers did something that had never been done. They pointed the James Webb Space Telescope, the most powerful eye humanity has ever placed in space, built to study the first galaxies at the edge of time, at a single asteroid that might hit us. It was the first time Webb had been used this way for planetary defense. A team led by Andy Rivkin at the Johns Hopkins University Applied Physics Laboratory observed 2024 YR4 with Webb's mid-infrared instrument on March 26, 2025, and again that May, reading the asteroid's warmth against the cold of space. There is something worth pausing on in that image. An instrument designed to look back 13 billion years, turned around and aimed at a rock in our own neighbourhood, because that rock had a small chance of reaching us. The same machine we used to ask where we came from, pressed into service to ask whether we were safe. Rivkin's team would later describe this as a new regime for planetary defence. The first time our most sensitive telescope had been used to characterise a possible impactor, and proof that we now had a way to reach out and study the small, faint, dangerous objects that ground telescopes lose almost as soon as they find them. By the time Webb looked, the asteroid had already dimmed to the edge of what anything on Earth could track. Webb could still see it. That mattered more than anyone wanted it to. Webb gave us the true measure of the thing. 60 metres across, give or take 7. About the length of a large passenger jet tumbling through space. Its surface reflects only 8 to 18% of the light that hits it, the signature of a stony body. An S-type asteroid, ordinary in composition, extraordinary only in where it had been pointed. 60 metres is a specific and meaningful size. It is not a world-ender. It would not darken the skies or threaten our species. It is what planetary defence scientists call a city killer, large enough to destroy a metropolitan area, small enough that we are genuinely bad at finding them. The comparison that keeps coming up is the Tunguska event of 1908, when an object in roughly this class exploded over Siberia and flattened some 2,000 square kilometres of forest, a blast that would have levelled any city it found beneath it. There was no crater. There did not need to be one. Webb saw something stranger too. This rock spins fast, a full rotation in just under 20 minutes. That is quick enough to matter, because a loosely bound pile of rubble spinning that fast would tend to fling itself apart. The fact that 2024 YR4 holds together hints that it may be a more solid, coherent stone rather than a gravel heap, and a solid stone delivers its energy all at once. It does not soften, it does not scatter. It arrives. With Earth cleared, most people stopped paying attention. The story had a happy ending, and the news moved on. But inside the numbers, the threat had simply changed targets. As the observations piled up through 2025, a small chance remained that 2024 YR4 would strike not the Earth, but the Moon, on that same December date in 2032. And in a repeat of the earlier pattern, that lunar probability climbed. After Webb's May observations, it stood near 3.8%. By the middle of the year, it had risen to roughly 4.3%. For a stretch of months, the single most likely dramatic outcome for this object was a direct hit on the face of the Moon. There is a grim symmetry to that. The same widening then narrowing dance that had briefly aimed the rock at Earth was now playing out again with the Moon inside the cone. And once more the odds rose before anyone knew which way they would settle. For the first time, we were watching a possible impact on another world unfold in real time, with the ability to calculate it years in advance. At first that sounds like a curiosity. The Moon is a dead world, pockmarked by billions of years of impacts. What is one more crater? But a scientist named Paul Wiegert at Western University in Canada ran the numbers on what a strike would actually mean, and the answer reached farther than the Moon. It reached back toward us. Because in the years since Apophis was found, we had quietly filled the space just above our heads with thousands of satellites, and that changes what a lunar impact costs. Picture the impact for a moment. A 60-metre stone hitting the lunar surface at tens of thousands of kilometres per hour, releasing energy on the order of 6.5 megatons, hundreds of times the bomb that ended a war, and punching out a fresh crater roughly 1 kilometre wide. On the airless Moon, there is nothing to slow the debris. Rock and dust would be thrown off the surface at tremendous speed, some of it fast enough to escape the moon's gravity entirely and drift toward us. Most of it would burn harmlessly in our atmosphere, a meteor shower unlike anything in living memory. The sky streaked for days on end, but a fraction of that debris would find the layer of orbit where we keep the machinery of modern life. The satellites that carry our messages, guide our ships and planes, time our transactions, and watch our weather. Wiegert's team estimated that the spacecraft in low Earth orbit could be struck by hundreds to thousands of millimetre-scale fragments, grains too small to see, moving fast enough to crack a solar panel or blind a sensor, a hazard lasting anywhere from days to months. Picture standing on the surface of the moon and watching it happen. You would see a silent white flash, no sound at all, and a slow bloom of dust rising straight up in the vacuum, climbing higher than any dust could climb on Earth, because there is no air to hold it back. Some of that dust would simply keep going, up and out, on a 3-day fall toward a blue point of light in your sky. And then, 400,000 kilometers away, in the orbits above the heads of everyone you have ever known, the consequences would arrive quietly. A scatter of pinpricks against the fleet we have come to depend on without ever looking up at it. A rock that could never touch the ground could still reach into the things that ground now runs on. That is the shape of the modern threat. It does not have to hit us to hurt us. The moon was spared. In February of 2026, a fresh round of James Webb observations tightened the orbit one last time and eliminated the lunar impact as well. On March 5, 2026, NASA and the European Space Agency announced that 2024 YR4 would miss the moon, passing it by about 21,000 kilometers when it returns in 2032. Earth safe, moon safe, the file closed, and yet the thing that should stay with you is not the all clear. It is where the object is right now. 2024 YR4 has faded beyond the reach of even our best telescopes, lost in the glare of the sun, running silent along a path we can no longer watch. We will not get another clear look at it until it swings back toward us on December 17, 2028. Only then can we extend its track and see how the coming decades unfold. It is still out there, exactly where it always was. We simply can no longer see it. So the story does not really end with safety. It ends with a rock going dark on a known orbit, and a calendar we will not be able to check again for years. Strip away the drama and one fact remains, and it is the one that matters. 2024 YR4 was a full rehearsal of everything we built to protect ourselves, and the rehearsal was both a success and a warning. The protocols activated for the first time in history. The world's telescopes turned as one. Webb delivered the truth. The system worked exactly as designed, and still, it found the most dangerous asteroid ever catalogued 2 days after it had already passed us. That is the lesson buried under the good news. An object this size announces itself when it is brightest, and it is brightest when it is closest, and by the time it is closest, it is often already leaving. We have found and tracked nearly all of the true monsters, the kilometre-scale rocks that could end a civilization. It is the middle range, the 60-metre city killers, the Tunguska class, where our maps still have holes. There are estimated to be many thousands of them, and we have found only a fraction. They are large enough to level a city and small enough to slip through, and 2024 YR4 is what one looks like when it slips. Consider the part we were spared from asking. If the odds had not fallen, if that 3% had held or climbed, we would have had roughly 7 years to do something no one has ever done to a live threat. We have tested the idea once, when a spacecraft deliberately struck a harmless asteroid and nudged its orbit, proof that deflection is possible in principle. but possible in principle and ready in time are different things. And 2024 YR4 never gave us the chance to learn which one we were. The 3.1% that made this rock the most dangerous we had ever tracked was never really about this rock. It was a preview. Somewhere out there is another 60-meter stone we have not found, moving along an orbit we have not drawn, and the first time we see it may be the same way we saw this one, in the rear view as it goes by. 2024, YR4 missed. The next one is a coin we have not yet flipped. We built a system to give us the last alert, and it caught this one late but harmless, a gift of a near miss we did nothing to earn. The sky gave us a warning shot and let us keep watching. The only real question this story leaves behind is whether the next city killer will be kind enough to miss us too, and whether we will see it in time to know. Thanks for watching, and I'll see you in the next one.